Hello friends, I am an aptitude trainer from the Department of Career Planning and Development. The topic that we have started today, that is number system, and under this chapter that we are going to do the concepts of unit digit and the concept of last two digits of high powered values. So let's start the concept with the theoretical aspect. In this that we have the number system, the concept of unit digit. To understand this concept, we just need to be familiar with the concept of cyclicity. As this approach of cyclicity we are going to use to have the last digit of any high powered value. Like say, the concept of cyclicity means we just need to understand what are the last digit of any high powered value who is having unit digit as one of the digits from 0 to 9. It means if we say any number like x power n, what could be the last or the unit digit of that number. So now whenever we considering the x, then we are not considering the full number, we're just taking the last digit of that number as well, mean the unit digit. That can be either 0, 1, 2, 3, 4, 5, 6, 7, 8 or 9. Mean the unit digit of this value x or the base value, we have any of these 10 digits and it may carry any number as a power of it. For that we just need to find the unit digit. Now just focus on the concept that we have. Firstly, we just need to do the number like the digit 0, 1, 5 and 6. What the specialty about these digits? The thing is that whatever the power we have, like for 0 power n or 1 power n, 5 power n or 6 power n, mean whatever the power we have for any of these four numbers, this unit digit is always as the number itself. Mean 0 always gives 0 as a unit digit, 1 always gives 1 as a unit digit, 5 is 5 and 6 is 6 as a unit digit. That means if we have an example, mean the question like find the unit digit of the following numbers like 185 power 563, 18 is not significance here, mean the value 5 power 563 we just need to find, where 5 power anything gives us 5 as the answer. 271 power 6987, 27 has no significance, 1 power anything gives us 1 as the answer. 156, 15 has no significance, 6 power anything gives 6 as a unit digit. 190, where 0 we have as a unit digit, so 0 power anything gives 0 as a unit digit of the question. Now after that what we need to understand, the concept of 4 and 9. Here we have the digit 4 and 9. For both the digits we have the cyclicity of only two different digits, like for the number as their unit digit. Let's say if we have 4 power 1, 4 power 1 ends with 4 and 4 power 2 ends with 6 as the number is 16. If we continue with 4 power 3, the answer is 64 and 4 power 4 gives us 216. That means unit digit is either 4 or 6. For that we just need to understand the cyclicity of 4 carries only two numbers, that is 4 and 6, which appears in the case of odd powers and even powers. The same we have for the value 9. 9 power 1 is 9, 9 power 2 is 81, so unit digit is 1, 9 power 3 is 729, so unit digit is again same, that is 9. That means 9 is also having the two digit number as its unit digit, that 9 or 1, which is also appeared for the odd and the even values. So what we are supposed to understand by using this, 4 power odd, whenever this thing we have, the answer is always 4 as a unit digit, where 4 power even always gives 6 as a unit digit. If we do the same thing for 9, the rule is 9 power odd gives us 9 as a unit digit, where 9 power even gives 1 as a unit digit. So it is all about these two numbers. The rest number what we have, the number like 2, 3, 7 and 8. All this number has a cyclicity of 4 different values, like what we can say 2 power 1 is 2, 2 power 2 is 4, 2 power 3 is 8, 2 power 4 is 16. It means the cyclicity of 2 is 2, 4, 8 and 6. These 4 numbers we have. If we find any other number after that like 2 power 5, that is 32, that also ends with 2. Then we have 64 ends with 4, 128 ends with 8 and 256 ends with 6. In this way we have the answer for 2 power anything. It means the cyclicity of 2 is 2486. In the same manner, the cyclicity of 3 is 3 power 1 is 3, 3 power 2 is 9, 3 power 3 is 27, so 27 is the unit digit. 3 power 4 is 81, so 18 is the unit digit. Again, the 3 has 4 different numbers as a unit digit, that can be 3, 9, 7 or 1. In the same logic, we have the cyclicity for 7 and 8. The thing is that whenever we have the cyclicity of any 4 values, that means we just need to divide the value by 4 and check what the remainder is. Here we have the 4 different values. The first value defines for remainder 1, then we have for remainder 2, third we have for remainder 3, and fourth we have for remainder 0. So what we supposed to do, if we have x power n, we just need to divide n by 4 and need to check what should be the remainder. If remainder is 1, in the cyclicity first value is the answer, for remainder 2 second value is the answer, remainder 3 third value, and remainder 0 the fourth value we may have. Now here we have the cyclicity table. As we discussed by the examples, that the cyclicity table we have for the digits, that is a single digit we have. The digit we have in this way, where 10 can be written as 0 as well. So we can say the cyclicity of 1 is 1, 2 is 4, 3 is 4, 4 is 2, 5 is 1, 6 is 1, 7 is 4, 8 is 4, 9 is 2, and 10 is 1. In this way, and these are the power cycles we have, mean the value we may have as the power or the unit digit of the high powered numbers. Now by this we have some practice question over the same concept. Like if we need to find the unit digit of 7 power 95 minus 3 power 58. Here we have the value 7 and 3 both has a cyclicity of 4. So what we need to divide, that is 7 power 95 divided by 4. If 95 divided by 4, the remainder we have as 3, and 7 power 3, if we say the unit digit we may have as 3. Now next what we have, 3 power 58, as it has also the cyclicity of 4, we just need to divide 58 by 4, that gives us the remainder as 2, and 3 power 2 gives us the unit digit as 9. So what we have, the first unit digit is 3, 7 unit digit is 9, answer is minus 6, which is not possible. So whenever the answer we have in the negative, we just subtract it from 10 to have the answer, that is 4. It means the unit digit of this expression is 4. Now the next what we have, 287 power 562 581. Here 287 we have, so 28 has no significance. We just need to find the 7 power this, and if the power is very big, we just need to find the last 2 digit, the divisibility of last 2 digit, which is 81. 81 by 4, the remainder is 1, and for 7 power 1, unit digit is 7 itself. So this is the answer for this question, that is 7, the unit digit of this expression. Now the unit digit of expression this, that is 6324. Here 632 has no significance, 4 power this. 615 power 316, 61 has no significance, 5 power something. And 341 power 476, here 34 has no significance. Now here we have 4 power something, and the power is odd. In this case unit digit is 4. For the second one, 5 power something is 5, 1 power something is 1. Hence the multiplication of this is 20, which gives us the unit digit as 0. That is the answer for this question. The third question, the unit digit of 7 power 295, 3 power 158, and 341 power 476. For this, 34 has no significance. 3 power something, it means we just need to check the divisibility of power by 4. If the power is big, we just need to divide the last 2 digit. 95 by 4, the remainder we have as 1. Remainder we have as 2, and 4 remainder 2, the unit digit of 7 what we have, that is 9. 3 power 158, 158 to be divided by 4, and the remainder that we have as 2, and 3 power 2 again, the number is 9 we have. The next is 1 power something gives us 1 as the answer. Here 9 into 9 is 81, so 1 is the unit digit. That's the answer for this question. The last question is very interesting and very complex sort of question we may have. If a is a positive integer and the unit digit of a square is 9 and the unit digit of a plus 1 square is 4, then what is the value of unit digit of a plus 2 square? Now if a square is 9, what could be the possible value of a? Now if we under root mean if we square any single digit number that gives us unit digit as 9, so the value may be 3 or 7. But if we say 3 plus 1, that is 4, 4 square gives us 16, so 6 is the unit digit, that's not satisfied the given condition. But if we take a as 7, so 7 plus 1 is 8, 8 square is 64, that is the significance we have here. It means the value of a is 7, not 3. So now if a is 7, then we can solve this a plus 2 square, which is written as 7 plus 2 square, that is 9 square, answer is 81, hence the unit digit of this expression is 1. After that we have the concept to find the last two digit, and the last two digit divide among various categories. The first category where we have to find the last two digit of a square of any number. Whenever we supposed to do this, like an example of 78. Now whenever we need to find the last two digit of any square value, what we need to do? We just need to understand the squares up to 25. That's a very important thing and the prerequisite of this. The first 25 natural numbers to square we need to memorize. Now suppose we need to find the 78 square, which is equals as 100 minus 22 whole square. That further can be simplified by using the formula of a minus b whole square, that is a square minus 2ab plus b square. If we expand this, the answer we have is 10,000 plus 4,400 plus 484. That means its sum depends upon the sum of these three, mean the addition or subtraction of these three values, where the last two digit depends upon the 84, which is the square of 22 as well. It means what we need to understood, if we need to find this last two digit of 72 square, which is equals to 100 minus 22 square, it has the same last two digit as 22 square. Mean either to find 72 squares last two digit or 22 squares last two digit, both gives you the same answer as 84. Let's have another example as well. If we need to find 61 square, now 61 can be written as 50 plus 11 square. So either to find 61 square or to find 11 square, we have the same unit digit, last two digit, that is 21. That means whatever the value we have, just reduces to the nearby 100 or the 50th multiple to have the last two digit of the given value. Now the next what we have, in the next example or in the next category, we just need to find the tens place digit of any number which is having the unit digits to 1. Like we have the number 31 power 76. A number is having unit digit as 76, unit digit as 1, mean 31 power 76, unit digit is 1, 1 power 76 we have. Then what we need to do? It always gives us unit digit as 1. It means to find the last two digit, we just need to find the tens place digit, and that can be found by just having the product of the unit digit of the power with the tens place of the base. Like as we need to find 31 power 76, so 3 into 6, that is 18. 3 into 6 is 18. So 18 has unit digit as 8, which is considered as the tens place value for the 31 power 76, that is 8. And it always has 1 as a unit digit, so last two digit is 81. To verify the result, we can just follow the concept of binomial expansion. Let's try to understand some other aspect of this. Like here we have the last two digit of odd numbers that ends with 3, 7 or 9. What is the specialty of these numbers? These numbers have some powers like n, which gives us a number whose unit digit is 1. So we just need to make these number or the value of these numbers which carries unit digit as 1, so as further we can solve the number as we solved the previous value that ends with 1. Suppose we have the example like 79 power 64. We just need to squaring the value until we have the unit digit as 1. Now 79 power 64, that can be written as 79 square power 32. Now if we solve 79 square, the double digit what we have, the same as 21 square, which is 41. So what we supposed to do? We just need to solve 41 power 32. Mean instead of whole this, we can just write 41 power 32. Now 41 power 32, 4 to the 8, that is the tens place, and 1 always gives 1 as a single digit, that is 81 is the answer for this question. Now the next thing what we have, the next thing is very interesting, where we're just finding the last two digit of an even number. Now here what we have, the last two digit of the number, like 24 power odd is always 24, whereas 24 power even is always 76. And one more thing, the 76 power any natural number gives us 76 as the last two digit. Now suppose here we have the example, we need to find the last two digit of 2 power 34. So 2 power 34 can be written as 2 power 30 power 4, that further can be expanded as 2 power 10 power 3 into 2 power 4. 2 power 10 gives us the value like 1024. We are just interested in the last two digit. So we just take 1024 as 24 power 3 multiplied by 2 power 4. 24 power anything that is odd, that gives 24 as the same number. 24 into 16, if we solve this, the last two digit is 84 we have. Now the last concept and the very important concept of this, whenever we need to find the tens place digit of the number that ends with 5, here the table that we have, whenever we have the number that ends with 5, suppose 35 power 163, in other words what we can have, n power x, right? This thing we have n5 power x. Here we just need to consider two things, that is the tens place of the base value and the power number as well. Now if the tens digit of the number that can be even or unit digit of the power that is even, the last two digit is 25 always, whereas the tens digit of a number is even and the power is odd, answer is 25 again. Where the tens digit is odd and the unit digit of power is even, answer is again 25. But where the number tens digit is odd and the power is odd as well, the last two digit is 75. Let's say for example, suppose 135 power 129. Now 5 is preceded by 13, which is an odd number, and 129 is a power that is also odd. So whatever the answer, that doesn't matter, the last two digit mean the unit digit must be 75. So this is the concept we have for the value that is the multiple of 5. Now the last, we need to practice few questions like 135 power 123. Here we just need to understand 5 is preceded by 13, which is an odd number, and 123 is also an odd number. Whenever both the numbers are odd, the last two digit is 75, that is the answer for this question. Whereas the next thing what we have, 62 power 48. This further can be written as 62 power 48 can be written as 31 into 2 power 48. That simplifies as 31 power 48 into 2 power 48. Now 31 power 48, 3 8 the 24, that gives us 41 as the unit digit, whereas 2 power 48 can be written as 2 power 10 power 4 multiplied by 2 power 8. Now if we expand that, that gives us 41 into 24 power 4 into 256, as we interested in the last two digits, that's 56. Here we have 41, 24 power odd, that gives us 76 multiplied by 56. If we expand this expression, the last two digits we have as 96. So now that is the answer for this question, mean the last two digit of this question is 96. And the last one we have 7 power 2008. Now we can understand how to make 7 with the unit digit as 1. So if we just write it as 7 power 4 power 502, that further can be expanded as, if we write 7 power 4, that gives us the last two digit as 01, which is 01 power 502, that always gives us 01 as the last two digit. Hence this is the answer for this question. So friends, it is all about the last two digit and the unit digit of high powered value. Thank you so much for watching this. Have a great day. Bye bye and take care.